Lesson 1, Introduction to Statistics. The objectives in this lesson are to distinguish between population and sample, and to distinguish between parameters and statistics. What is statistics? Statistics is a field of study within mathematics. The field of statistics is a collection of procedures and principles for gathering and analyzing data so that informed decisions can be made. There are three major branches of statistics. Descriptive statistics, which is the branch of statistics that involves the organization, summarization, and display of data. Probability is a basic tool in the study of inferential statistics and is the mathematical backbone of inferential statistics. And then inferential statistics is the branch of statistics that involves using a sample to draw a conclusion about a population. We'll study all three of these, and need to get my pen out. There we go. We'll study all three of these. We will do descriptive statistics in the beginning of the semester. We'll do probability in the middle of the semester. And we'll do inferential statistics in the end of the semester. Each of these will be broken down. Really, it's about a third of the material, but we'll fly pretty quickly through the descriptive statistics because much of it will be review for you. There are a number of basic terms that you need to learn for statistics, just like you would for any new field. And the first one is population. A population is a particular group of interest. A sample is a subset of that population from which data are collected. Now, I can illustrate what this looks like. The population, if it's represented by a large oval, and anything could be in this population. In this case, I'm just going to have X's. It could be people or dogs. That's not an X. And when we take a sample of this population, or we take a sample from this population, it's just some subset of that population. So be mindful of the relationship between a population and a sample. The large oval represents that entire population, and the smaller oval represents the sample, which is chosen hopefully randomly from the population. A variable is a value or characteristic to be observed or measured from individuals in the population or sample. It's the question that we want answered. Data are the counts, measurements, or observations gathered about a specific variable. A parameter is a numerical measure of a population characteristic. The parameter is fixed. That means there's only one. There's only one median for a specific population. So if we were to calculate the median, there would be only one. A sample statistic is a numerical measure of a sample characteristic. The median of a sample will depend on the values in that sample. 3 different samples from the same population may have 3 different medians. Now, if we were to compare a population and sample to one another, the population would be the whole group. It's the group we want to know about, and the characteristics that represent this group are called parameters. Parameters are almost always unknown, and they're fixed, which means there's only one for each parameter. In a sample, the sample is part of the entire group. It's the group we actually know about. The characteristics of that group are called statistics, and statistics are always known or can be calculated, and statistics change with the sample. So let's look at some examples of populations versus samples and parameters versus statistics. In a recent study of 1,329 high school volunteers, those who had 8 hours of sleep were 3 times more likely to answer correctly on a math test than were sleep-deprived participants. You're asked to identify the sample and identify the population. The sample is this 1,329 high school volunteers. The population is not given to us here, but it is implied, and that's all high school students. Next example. A survey of 1,125 households in the United States found that 24% subscribe to satellite radio. You're asked to identify the sample, identify the population, and determine whether the highlighted value is a parameter or a statistic. The sample is the 1,125 households in the U.S. The population is implied again. It's all households in the U.S. The highlighted value is this 24%, and because the 24% is coming from the 1,125 households, it's a statistic. And that's because it comes from the sample. All right, let's do another example. The 2003 team payroll of the Baltimore Orioles was $73,877,500. We're asked to identify the sample, the population, and determine if that highlighted value is a parameter or a statistic. In this case, the 2000 team payroll is the entire team, or all of it. So that's the population. So the 2003 team payroll is the entire population, or the 2003 team, sorry. So there is no sample here. And then we're asked to determine if this highlighted value, the 73 million and change, is a parameter or a statistic. So that 73,877,500 is a parameter. And that's because it's coming from the population. So when we are trying to determine between sample and statistic and parameter and population, sample data gives us statistics, or numerical measures that come from samples. Populations give us parameters. So values that come from the population are parameters. Thank you for joining me for Lesson 1.